Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 4. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as an independent current source IS. Additionally, we can observe the presence of a dependent source, especially a current-controlled current source. The question now is to calculate the voltage values at the nodes. Let's move on to the solution. First, let's start by labeling all the nodes in the circuit. And I will consider this node as node 1, this node as node 2, and this node as node 3. After, we will assign the voltages V1, V2, and V3 respectively to those 3 nodes. Next, we need to select a reference node in the circuits. The reference node is typically chosen as the node with the most connections, or as the ground node. Let's now assign arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1, and I2 is the current through the resistor R3, and I3 is the current through the resistor R4. Next, we will proceed to apply Kirchhoff's current law in each node. Let's start first by applying Kirchhoff's current law at node 1. We can write IS is equal to I3 plus I1. And if we replace IS with its numerical value, we obtain I1 plus I3 is equal to 4. Let's move on now to node 2. By applying KCL at node 2, we can write I1 is equal to Ix minus 4Ix. That means I1 is equal to negative 3Ix. Let's move on to node 3. By applying Kirchhoff's current law at node 3, we can write I2 is equal to I3 minus 4Ix. According to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equations. I1 is given by V1 minus V2 over R1, and I2 is equal to V3 minus 0 over R3, and I3 is equal to V1 minus V3 over R4, and Ix is equal to V2 minus 0 over R2. By substituting now A and C in 1, we can write 4 is equal to V1 minus V2 over R1 plus V1 minus V3 over R4, and if we replace the resistors with their numerical values, we obtain this expression. If we continue simplifying this equation, we obtain finally 5V1 minus 2V2 minus 3V3 minus 24 is equal to 0. Now, by substituting A and D in 2, we obtain V1 minus V2 over R1 is equal to negative 3V2 over R2. And if we replace the resistors with their numerical values, we obtain this equation. And if we continue simplifying this equation, we obtain finally 4V1 plus 5V2 is equal to 0. Let's move on now by substituting B, C, and D in 3. We obtain V3 over R3 is equal to V1 minus V3 over R4 minus 4V2 over R2. By replacing the resistors with their numerical values, we obtain this expression. And if we continue simplifying this equation, we obtain 3V1 minus 6V2 minus 4V3 is equal to 0. After we finish applying the nodal analysis method, we obtain 3 equations with the 3 unknowns. Let's start first with equation 5. From equation 5, we can write V1 is equal to negative 5 over 4 V2. And by substituting now A in equation 6, we can write negative 15 over 4 V2 minus 6 V2 minus 4 V3. If we continue simplifying this equation, we obtain V3 is equal to negative 39 over 16 V2. I write here V3 in terms of V2. Now by substituting A and B in 4, we derive one equation in terms of V2. And if we continue simplifying this equation, we obtain negative 15 over 16 V2 minus 24 is equal to 0. That means V2 is equal to negative 384 over 15 is equal to negative 25.6 volt. And from equation A, we have V1 is equal to negative 5 over 4 V2. If we replace V2 with its numerical value, we obtain V1 is equal to 1920 over 60 is equal to 32 volt. And from equation B, we have V3 is equal to negative 39 over 16 V2. By replacing V2 with its numerical value, we obtain V3 is equal to 14,976 over 240 is equal to 62.4 volt. After completing the calculation, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here our network drawn in SPICE simulator. We can see here this is the independent current source IS. This is the controlled or dependent source, a current controlled current source. And we can see here this is a resistor R1, R2, R3 and R4. We connect here a voltmeter to measure the node voltage V1, and this voltmeter to measure the node voltage V2, and this voltmeter to measure the node voltage V3. Let's move on to analysis, DC analysis, calculate nodal voltage. We can see here that V1 is equal to 32, V2 is equal to negative 25.6 volt, and V3 is equal to 62.4 volt. Upon completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation result. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video. Take care and bye bye.